Greetings to all. My name is Leonardo Moreira. I will present the paper entitled An Autonomic System for Energy Cost Reduction in Computer Labs. All the authors of this paper are from the Federal University of Ceará, Fortaleza City, Brazil. This work is motivated by knowledge in the areas of smart cities and green computing, applying this knowledge in computer labs. In universities and research institutions, it is very common to use computer labs. However, idle computers can impact unnecessary energy expenditure and also have a negative impact on the emission of carbon dioxide. For our study, we designed and implemented a tool called Smart Lab to reduce power consumption in computer labs by identifying and turning off idle computers. To validate Smart Lab, we evaluated the reduction rate of energy expenditure and carbon dioxide emission. This slide illustrates the overview of the Smart Lab system architecture. The architecture is designed to manage several computer labs in the same institution. For this, a mobile application is provided and allows laboratory managers to see the status of each laboratory. Each computer lab has sensors to capture data from the environment, such as lighting, temperature, and presence data. The machine controller component is installed on each computer in the lab. This component is an agent for capturing data from computers and is also used to execute commands locally, such as the shutdown command. The coordinator controller is the central computer of the laboratory that serves to host the Smart Lab management service. In addition, this component has the function of sending the state of each laboratory to the mobile application. To implement the Smart Lab architecture, we use the Java language to implement the agent and coordinator. All captured data were stored in a Postgre database. The coordinator was implemented was a web service layer using the data exchange by JSON. The sensors were implemented using Arduinos. The RxTX library was used for integration between Java and Arduino. The mobile application was implemented using the Swift language for the iOS operating system. All communication between the mobile application and the coordinator was done with JSON. This slide shows some screens of the mobile application that is used by the lab managers. The first screen displays the list of labs that the Smart Lab is managing. The second screen is displayed when a lab is selected. On this screen are all the computers that are currently connected in the selected lab. When you select a computer, the third screen appears. In this screen, it is possible to see the captured data of the environment, such as the luminosity, temperature, and if it is being used. That is, some person presence was detected in the laboratory. It also shows data related to the computer, such as operation system, number of processes, and free main memory. Finally, a button appears that forces the computer to shut down. Our experimental evaluation aims to show the Smart Lab system reduces carbon emissions and therefore reduce the cost of energy spent in the use of computer labs. Thus, our results show the reduction of kilowatt per hour and carbon emissions reached by Smart Lab. For experimental scenario, a laboratory with 19 computers was used. One of them was used for the coordinator. The remaining 18 machines had the agent deployed to monitor and execution of the operating system commands. Four Arduinos Mega was arranged at different points of the laboratory. We used an iPhone 5C and an iPad Air for data visualization obtained by SmartLab web service deployed on the coordinator. An overview of the experimental scenario can be seen in this slide in left side. The chart on the right side of this slide shows the result obtained in a typical situation in the last class time of the night in our undergraduate course. All laboratory computers are scheduled to shut down after 10 p.m. In this experiment, we would like to check the gain obtained by identifying idleness on the 18 computers in this last class time. We put in a situation where the idleness of the 18 computers was identified by the Smart Lab in the time of 8 p.m. The Smart Lab identified idleness after 32 minutes. From the results, the cost of energy reduction was 2.16 kW per hour in the total of the experiment. As a conclusion, SmartLab was presented, its architecture discussed and implemented. Experiments conducted showed that SmartLab has reduced energy expenditure on idle computers. As future work, we plan to evaluate SmartLab in new scenarios and different situations. We pretend to use more metrics to better identify the idleness of computers. Thanks for your attention. Any question, please send me an email.